name's Glenn. I'm a software engineer at Liberty IT, and I'm going to run through serverless first, case studies from an enterprise. So I'm going to start off a little bit with who am I, and I'll keep it brief. So this is who am I in 60 seconds. So I wasn't always a software engineer. I had a degree in biology back whenever I had hair and good posture. Couldn't get a job from it, so I hid in academia for another 4 years, where at the end of that I came out with some resplendent robes and a PhD in molecular biology. So what did I do with this specialist knowledge? I got a job working as a tour guide for Titanic Belfast, where I learned all sorts of really useful facts about that ill-fated ship. After that, I spent a year working as a patent analyst for a major law firm. Realized law wasn't really my thing, so I went back to uni again, this time to get a software engineer degree, where I also lost my hair, unfortunately, but I did gain a beard. After that, I got a job in my dream industry, which is software development, working for Liberty IT, where I get to dabble in machine learning. This is me on AWS's Deep Racer TV. Get to talk about serverless, and of course get to do what I really enjoy doing every day, which is writing code. So just a little bit about Liberty IT. They're the software house of insurance giant Liberty Mutual. We have offices both in Belfast and Dublin, with around 400 staff between those two. So into the main event. What is serverless, and more importantly, why is serverless? So before cloud providers, we had data centers and we had on-prem server farms. So this was very slow. I'll not labor the point too much, but it wasn't great at handling peak traffic, and scaling was a nightmare. In short, it just wasn't agile. It was slow, potentially inefficient and expensive, depending on the use case. With that in mind, what is serverless? So it's a bit of a misnomer, because there are still servers actually involved. You can see a lovely, nice server room there of Amazon's. So it's not really that there are no servers, but it'd be more accurate to say that it's kind of about worrying less about servers. So that was my favorite slide in this whole presentation. But even with that in mind, it's actually quite hard to define what serverless is. There are quite a lot of blogs, and there are a lot of discussions still online that are actively talking about what is and what is not serverless architecture. Fortunately for us, Amazon Web Services have put together 4 qualities that they think architecture has to have to be considered serverless architecture. So the first one we've already sort of touched on. There are no servers to manage, so we don't have to provision servers, store them, update them, and this has sort of been covered already in the talks this morning. But this really is a huge key feature of it. You don't need to worry about infrastructure. You can actually just focus on the business problem at hand. Much like the superlative Nokia 3210, my first ever mobile phone, serverless is generally considered pay-as-you-go. So you don't have to have a really powerful instance running 24/7 for peak traffic that only happens once a day. You only pay for, in the case of functions as a service, for example, the functions that are actually invoked. It's inherently scalable, so architecture that you design to work for low levels of traffic or even small companies will work really well without having to have any real input after the fact, assuming it's architected well from the start, of course. It'll work really well in huge enterprise industries with loads and loads of traffic going through. And finally, it's got resiliency and availability baked in. So this is a map of different AWS data centers around the world. And this has 2 really big advantages. One is of performance. If you have customers halfway around the world and you have only one server farm or one data center, then the traffic's going to have to travel all the way around the world before the response comes back to them. It just adds time. Whereas in this scenario, the traffic will be routed via their nearest data center. It also means if anything should happen to any of the your on-prem site, then you're in trouble. But again, with the likes of AWS and other cloud providers, that data and that service will be backed up all around the world. So what does that look like in practice? Just notice this emoji's different. It'll still work. So looking at something that we would have seen maybe a few months back, whenever people were stealing everyone's data, if you imagine an app where you take a photo, you put that photo through a filter, and it makes you look old, and it's all very fun. If you imagine this in a serverless way, you've got your users here. The traffic's routed through API Gateway, which is an Amazon Web Services microservice. And then it goes to a Lambda function that does all the filtering, changes the photo, and then this is stored somewhere, in this case, an S3 storage bucket. And then the user can retrieve that on their phone and have a bit of a laugh at it. So what happens if a popular influencer picks up on this app and starts taking photos and it becomes incredibly popular? Suddenly your user base has gone up tenfold. Well, that's no problem. It's just more Lambda functions will be spun up and it'll handle the traffic seamlessly. There'll be virtually no notice on the other side of things. You will, of course, start getting charged more money because you have more functions being spun up. But it works both ways. Once another thing comes along, something that maybe makes you bald, and your user base drops off and they get bored, then so do your Lambda functions. These start getting spun down, and it instantly starts saving you money. So at this stage, it's also important to note out that serverless isn't inherently and necessarily functions as a service. If you have functions as a service set up, you can still have architecture that isn't serverless, and vice versa. You can have architecture that is serverless and isn't functions as a service platform. So what about serverless at Liberty? Going to start off with a bit of a timeline. So 2014 saw the start of our public cloud journey. And very shortly after that, whenever serverless came on the scene, people started experimenting with serverless and really seeing what it can do, kind of led by our public cloud team. By 2016, 10% of our workload was in the cloud, which is pretty impressive considering how old and how huge of a company that Liberty is. And in 2017, we had the launch of our first customer-facing serverless applications. So I'll be talking a bit more about those in a second. By 2018, we had 20% of our workload in the cloud, so it's really steadily more and more stuff's going onto the cloud. And then in 2019, the company adopted a serverless first approach. So what is serverless first? It's exactly what it sounds like on the tin. Really, whenever we're faced with new architecture problems or even new coding problems, or if we're just having a bit of a play in innovation time, we'll try to solve those using a serverless mentality. So what's really important about this is it's not a case of just shoehorning in serverless and getting serverless to work in cases where it should never actually work, or that it's going to be inefficient, or it's just not the right fit for. But it's trying it out first using a 100% serverless approach, and then slowly moving down and changing the services that you use until eventually you get down to just provisioning a huge VM. And there are cases where that is still the right use case. This was taken from a blog from Cloud Zero. You can see the link down there if you want to read a bit more about it. But it's just this concept that individual services aren't, yes or no serverless. It's not an on-off sort of thing. But serverless itself is a spectrum. And it's a really good resource that you should check it out. There's some more, again, examples of services that fall along that spectrum. So how did Liberty do it? In one phrase, I think, to sum it up, would be developer empowerment. So I talk about this public cloud vanguard. We had a public cloud team that was set up at the start of our cloud transformation. And this team were responsible for setting up different accounts in different cloud providers. They would set up sandbox accounts so developers could have a play. They would set up CI/CD pipelines so that very quickly you could get stuck in and just get stuff up into the cloud and even very quickly get it into a production environment. And they also established a lot of different patterns and kind of best practices. And off the back of those best practices, they made a serverless application called Radar. And what Radar does is it monitors any of the resources that are created by the developers, and it checks them against different sort of company best practices and really against, more importantly, security practices. So if you were creating something that could be dangerous or could expose a production environment, it just wouldn't be created. And while that sounds a little restrictive, it's actually really important so that people can go off and have a play and just really get stuck in knowing that they're not going to break anything. We were encouraged to chase after certifications. So there's lots of internal learning in the company. People will share any learnings they have from their own certification progress. And this really, when it comes to cloud engineering in particular, there's so many services out there and there's so much out there to learn that it's a really good groundwork to actually get stuck in and see what's there. More importantly than that, and my own personal favorites, this is a concept of innovation time. So developers at Liberty really should be spending about 10% of their time at work innovating and just trying out new things. And lots of really, really good applications have come off the back of this. And again, it plays back into the public cloud vanguard idea that with all the groundwork down, we can just jump in and start, spinning up our own applications and playing about with these things. Even I'm working on a personal website, just using a 100% serverless approach. Not that it's ever going to see the traffic to warrant that, but it's just fun to get stuck in and play with that sort of thing in the spare time. So I'm going to move on to kind of the main part of the talk, which is the case studies from 4 different areas in the company. And I feel that each of these areas has their own story to tell about serverless and has a big win from serverless attached to them. So the first one I want to talk about is our accident and health product. So this is a fairly standard insurance product if it protects you in the event of critical illness or an accident. When it came to renewing the software for this and creating a new application, we looked at how to do it in the old way, just a load of VMs spun up, and while in the cloud, maybe not the most efficient way of doing that. And we estimated that it was going to cost around $200,000 a year. So it's important to note that a big part of that cost was using a third-party document generation vendor. And if you think about an insurance product, there are quite a lot of moving pieces to it. You've got the website, you've got billing, you've got claims, and this document generation system. So as part of innovation, one of the teams decided that they were going to take a stab at doing the document generation using 100% event-driven architecture and make it 100% serverless. And the final cost of running the entire individual accident and health platform was $17 a year. Like $17, it was tiny. One of the team leads involved in this would frequently brag about how he would pay for the entire cloud hosting costs out of his own pocket. The next example I'm going to touch on is WorkGrid. So WorkGrid was an employee productivity tool that originally was just an internal application within Liberty Mutual. What it was used for was it essentially took all of the notifications that employees would be getting from different platforms, Outlook, Slack, Link, Skype or whatever, and would put it all into one place. They called them smart notifications, and it just really meant you weren't logging into multiple different vendors to actually find what was important. So eventually it was so successful internally that they decided that they were going to launch this as a separate startup. And it was originally a small team of around 4 to 5 developers. So the co-founder and the CTO actually proposed that they use serverless so they could really, work fast, and actually challenged the rest of the team to spin up a VM and then spin up a Lambda function and see which one was quicker. And it was unanimous after that they were going through with serverless. So that meant there was lots of fast experimentation within teams. There were new parts added to the product, a chatbot that employees could use to look up company policies, for example. And a real key part of the serverless story was that you don't need specific instances for different customers. If you have a 200 to 300 employee company, then you can use the same infrastructure that you'd use for that 2,000 to 3,000 or even 20,000 to 30,000 employee companies. And this application was incredibly successful. It's been recognized by Gartner, and it was also presented at AWS reInvent, which is the big Amazon Web Services conference of the year. Next is the finance ETL system. Very briefly, if you don't know what ETL is, it's basically extracting data from a source or multiple sources, transforming it into something that's useful and you can gain insight from, and then putting it into a database. In our finance system, there were millions of records being handled, and crucially, most of these were handled over 2 to 3 days per month. The rest of the time, the flow went down to a trickle. So this would have cost hundreds of thousands as an on-prem solution. It ended up costing in the low thousands, and obviously that's a huge win on its own. But again, serverless granted a lot of unexpected kind of benefits. One of which was the modularity of the architecture meant that you could easily switch out different things whenever new products became available. So in the case of these step functions, Amazon Web Services started this new Step Function Express workflow, which was specifically designed for dealing with high, huge levels of data. So with that in mind, they were able to very quickly put in this new workflow and instantly start saving thousands and thousands of pounds per month. So finally, the virtual assistant. I thought it was interesting to start with this quote about virtual assistants in general. The average person will have more conversations a day with bots than they do with their spouse in 2020. And I think this is something actually you can already see happening today. So our virtual assistant was firstly rolled out in the claims department. And really, the team wanted me to really express how important the engineering excellence was for this to be such a success. So this is the idea that you would still use really rigorous testing, TDD. You would make sure there's no coupling between different parts of the architecture. And also the massive win that they got from using managed services. As you can see in the picture there, it actually leveraged the same technology that Alexa uses. And without this team having to be real experts in how chatbots work, they were able to just use the AWS solution that was there. And again, this was called out as a best in class by AWS. And by 2019, this was saving the company around $4 million per year. So it was a huge, huge financial success. So I'm just going to finish off very quickly on my final thoughts on serverless. As a developer, I love it. I mentioned earlier about empowerment. It allows me to just very quickly get stuck in and have full control over every aspect of the architecture. It allows businesses to focus on their business problems, not the infrastructure, and there's potential for just huge, huge amounts of money to be saved. Just keep using excellent engineering practices and don't use it where it's not needed. And finally, I think it's a good point to make that all these examples that I gave were really huge, significant success stories for a Fortune 100 company. And all the thought leadership came out of Belfast, and all the engineering came out of Belfast. So we really have a great talent pool here. If you'd like to know more, there's a few links there. I'm sure these slides will be available afterwards. You can have a look. And that's me. If anybody has any questions, don't hesitate to get in touch. And thanks to Beltech for having me.